The following content is provided under a Creative Commons license. Your support will help MIT OpenCourseWare continue to offer high-quality educational resources for free. To make a donation or view additional materials from hundreds of MIT courses, visit MIT OpenCourseWare at ocw.mit.edu.
So these two courses are a continuation of the pioneering work done by Professor James R. Melcher, who died in 1991. He had written three books called Electromechanical Dynamics, Electromagnetic Fields and Energy, and Continuum Electromechanics. And the philosophy in those books are rigorous mathematics together with complete explanation of the physical principles involved. So a lot of qualitative nature so that you can develop a physical feel of how electromagnetic fields and forces result in motion and deformation of materials for some practical applications. But in addition to do rigorous mathematics. And these two courses, 6641 and 6642, try to follow in that rigorous tradition so that the students become very good at problem solving and gives them a very broad experience not only of electromagnetism but also the mechanics and material properties that these electromagnetic forces act on. Well, in Course 6, we have done a reorganization, revitalization of our fundamental undergraduate course on electromagnetism. It goes by the number 6.013, which is Electromagnetics and Applications. With the reorganization, we had gone from 2 required electromagnetic courses to 1, and we realized that a lot of good material was not being taught. And for those students whose areas of interest and research involved electromagnetism, we developed 2 new courses, 6.641, Electromagnetic Fields, Forces, and Motion, and 6.642, Continuum Electromechanics. Those 2 courses cover what we call magneto-quasistatics and electro-quasistatics, which is the important regime of electromagnetism for electromechanical interactions, basically machines of various types, actuators, electromechanical devices. Most lectures are focused on processes, devices, and practical applications of electromagnetism, so we try to build on that. And we often bring live demonstrations into the classroom that will demonstrate all the principles we're trying to teach and really prove that they do indeed happen. So in the case of fluids, we cover electrohydrodynamics, the interactions between electric fields and liquids, ferrohydrodynamics for magnetic liquids, and magnetohydrodynamics for conducting liquids, which have an interaction with the magnetic fields via the Lorentz force. Now, most people are probably not that familiar with magnetic fluids because they're not natural. They are a synthesized fluid. So I have a little demonstration. I have a vial of black liquid within a clear liquid, and when I bring a magnet near the magnetic fluid at a very critical strength, it breaks up into a very interesting spike kind of pattern, which is kind of a characteristic signature of magnetic fluids. And this occurs when the magnetic force just overcomes the stabilizing forces of gravity due to the density difference between the 2 liquids, and the surface tension that also tries to keep the liquid flat. So you can see the spikes form, or to do it the other way, we can make some black rain here. We can attract the fluid up to the top, and they watch it form and then sort of rain down. So we do a lot of ferrohydrodynamic work, magnetic fluids in their description. It's a classic hydrodynamic problem with the new ingredient of a magnetic driving force on the fluid. and it has very interesting properties, of which this is one example. And these peaking patterns are actually shown on the home page of 6.642. The two courses, 6.641 and 6.642, are Grad H courses and are concentration electives under the header of 6.013 in the concentration elective stream within EECS called Electrodynamics and Energy Systems. 6641 in particular is also considered an advanced topic area for the TQE, which is the technical qualifying exam required for Master of Engineering students. And by being an engineering concentration electives, they can fulfill the requirements for the MEng degree also, which require altogether 9 concentration electives for the Master of Engineering degree. And for those interested in electromagnetism, they can take one or the other of these two courses.